In this review problem, let's look at 427 and 428. Both concern the binomial theorem. The first problem, we take a look at 2x to the third minus 1 to the 24th problem. And the question is, find the term that, or the coefficient of the term that has x to the ninth in it. So we're not looking for the full expansion. The full expansion would go summation k equals 0 to 24 of 24 choose k times 2x to the third to the kth power times negative 1 to the 24 minus kth power. Now I'm not going to write this all out, I just need to figure out the term that has x to the ninth in it. The term that has x to the ninth in it is the one where k equals 3. So k equals 3, the term would be 24 choose 3 times 2x to the third times negative 1 to the 21st power. So that's the term that has x to the ninth in it. And so this works out to be 2024 times 8x to the ninth times negative 1. And that works out to be negative 16,129 x to the ninth. And so the coefficient would be negative 16,192. So that would be the answer for the coefficient. The term is negative 16,192 x to the ninth. The term itself would be negative 16,192. The next problem, expand and simplify 3 minus 2 square root of 2 to the 6th power. And write the answer as something plus something else times square root of 2, where the two somethings are integers. Okay, now to do this, we will take a look at the 6th row of Pascal's triangle, which I'm writing at the top of the screen right now. So there's the 6th row of Pascal's triangle. And so using the 6th row, 3 minus 2 square root of 2 to the 6th would be equal to 3 to the 6th plus 6 choose 1 times 3 to the 5th times negative 2 square root of 2 plus 6 choose 2 times 3 to the 4th times negative square root of 2 squared plus 6 choose 3 times 3 to the third times negative 2 square root of 2 to the third plus 6 choose 4 times 3 to the second times negative 2 square root of 2 to the fourth plus 6 choose 5 times 3 to the first negative 2 square root of 2 to the fifth, and then finally 6 choose 6 times 3 to the 0 negative 2 square root of 2 to the 6th power. So I'm going, there's 6 choose 0 is the first one here. So the term in Pascal's triangle increases. The power on the 3 is decreasing. The power on the negative 2 square root of 2 is increasing. 4, 5, 6. And they're all being added together. For practical purposes, it doesn't really matter which one is the x and which one's the y. If we were to start this on negative 2 square root of 2 and we're let it be 3, it would be all right. So it doesn't really matter which one is decreasing, which one is increasing, as long as you get them all, and the sum of the exponents on each term adds up to 6. Okay, so if we do the arithmetic here, this is going to be, well, let's see, 3 to the 6th is going to be 729. 6 choose 1 is 6, times 3 to the 5th is 243, times negative 2 square root of 2. 6 choose 2 is 15, times 3 to the 4th is 81, times negative 2 square root of 2 is 8. 6 choose 3 is 20. 3 to the third is 27. And negative 2 square root of 2 to the third power works out to be negative 16 square root of 2. Next line is going to be 6 choose 4 is 15 times 9 times negative 2 square root of 2 to the fourth, and that works out to be 64. Put that in parentheses so I can see which term is which. 6 choose 5 is 6, so 6 times 3 times multiplied by another negative 2 square root of 2, that's negative 128 square root of 2. And then lastly, 6 choose 6 is 1 times negative 2 square root of 2 to the third power, and that works out to be 512. Okay, so then it's just a matter of collecting terms. If we take all the things that don't have a square root in them, so if I take this one plus this one plus this one plus this one, all the things that don't have a square root of 2 in them, if I do the arithmetic right, I get 19,601. And then everything else is going to be something times the square root of 2. This, and this. And that, if I collect them together, it works out to be 13,860 times the square root of 2. And so this to the sixth is equal to this, and that would be the way of writing the answer exactly, as opposed to just plugging into a calculator and returning the decimal expansion.